This is part 1 for Secondary 1 Math, lesson number 11-5. We will begin with the warm-up for 11-5.
To multiply this polynomial, I need to distribute the negative 4m cubed through. So I have a negative 4 times a negative 5, which is 20. M to the third times m squared is m to the fifth. Negative 4 times 6 is negative 24. Then m to the third times m is m to the fourth. This is our answer right there for number 1. Okay, for number 2, the first thing we need to do is write it out twice. So we have a negative 7r plus 1 times negative 7r plus 1. We're going to distribute the negative 7r first, which gives us negative 7, oops, just kidding, that's not what it gives us. We get a negative 7 times a negative 7, which is a positive 49. R times r is r squared. Negative 7r times 1 is negative 7r. Then we're going to distribute the 1 through, so we get another negative 7r plus 1. Negative 7r and negative 7r are like terms, so we end up with, let's see if you can see it down here in the corner, 49r squared minus 14r plus 1. So there's your answer for number 2. On number 3, we're going to distribute the 4v through. 4v times 2v to the third is 8v to the fourth. 4v times a negative 5v is negative 20v squared. 4v times 3 is plus 12v. 7 times 2v to the third is 14v to the third. 7 times a negative 5v is negative 35v, and then 7 times 3 is 21. Our like terms, we have our only like terms here. Oh, let's see here. I missed my v on this one, didn't I? Put my v back there. Okay, our only like terms are 12v and negative 35v. So our answer is 8v to the fourth plus 14v to the third minus 20v squared minus 23v plus 21. And I got the 23v from a negative 12v plus a negative 35v. There's my answer. Now we're just going to find the degree of each one of these. I need to look at each one of these separately, each term separately. This has a degree 5. This has a degree 4. Since 5 is the greatest, this is a degree 5. Our next one, this is a degree 2, degree 1, degree 0. So we have 2, 1, 0, so 2 is my answer for that one. And our last one, we have a 4, a 3, a 2, a 1, and a 0, so our answer is 4. Okay, now we're going to factor each polynomial using the GCF. So we need to write it out. 32 breaks down into 2 times 2 times 2 times 2 times 2, and then 1, 2, 3, 4, 5 g's. Minus 2 times 2 times 2, g, 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 plus 2 times 2 times 3, g. So I just broke each one of those down. Okay, so they have in common, they each have two 2's. This one has 2 2's, and this one has 2 2's. And they each have a g. So my GCF is 4g, that goes on the outside. I'm left inside with the first term, 8g to the fourth minus 2g squared plus 3. This is my answer for number 4. Okay, number 5, once again, we're going to write it out. So 10 is 2 times 5bb plus 5b. They both have a 5b in common. So 5b is my GCF, and that goes on the outside. Left-hand side is a 2 and a b, plus, since I took everything out here, I have to have a 1 left over to hold my place. There's my answer. Okay, number 6, I'm going to write this down. 7n minus 3 times 7. I can see they each have a 7. So my GCF is 7, and I'm left with an n minus 3. And our last one, we have 3 times 3 with 4 c's plus 5 times 5. There's nothing they have in common, so the answer here is cannot be factored. All right, today we're going to talk about factoring trinomials. Again, we've already learned how to factor doing the GCF. This time we're going to do it a different way. And remember that factor means to undo the multiplication. Okay, so if we were to multiply this out, let's go forwards first, then we'll go backwards. We would do x times x, which is x squared, x times 5, which is 5x, negative 2 times x, which is negative 2x, and then negative 2 times 5, which is negative 10. We would see that we have like terms right here, so my answer would be x squared plus 3x subtract 10. So how can I go backwards? How can I go from x squared plus 3x minus 10 back to what I started with, which was x minus 2 times x plus 5. So I'm trying to figure out how can I go from here to here. Well, first of all, when we're factoring, we're always going to ask the following question. Is there a GCF? That's the first thing we want to do every time. Is there a GCF? If my answer is yes, then I'm going to factor it out like I did in lesson 11-4. If my answer is no, then we're going to factor into two binomials, just like we saw on the previous page. So where I'd have like x minus 2 times x plus 5. That would be two binomials. Okay, so if I have x squared plus 3x minus 10, let's go ahead and read this question here. When factoring a trinomial with a leading coefficient of 1, all that means is that this right here has a 1. That's a leading coefficient of 1. And to two binomials, ask the following question. What are the two numbers that when added together equal 3 and when multiplied equal negative 10? So what are the two numbers that when added together give me this 3 and when multiplied give me the negative 10? We're going to use something called X games to help us do this process. So factor each polynomial. The first thing I want to do is I want to ask myself those following questions. Number 1, is there a GCF? As I look through here, I can see that I have x plus 3x plus 2. There is no GCF, so my answer would be no. Since my answer is no, what are the two numbers? So we're going to fill in this blank here. Go ahead and add that. What two numbers, when added together, equal, I'm looking for 3, and when multiplied, equal 2. So what two numbers can you think of that when added together equal 3 and when multiplied equal 2? And hopefully you already know the answer. We're going to use what we call X games to figure out the answer. First of all, up here is where we put the number, the middle term. That's where we're looking for whether it's adding or not. And then the last term goes down here, and this is the one that's multiplied down here on the bottom of the X. So my first term the middle term was 3, and my last term, the third term, was 2. So what two numbers, when multiplied, give me 2, and when added, give me 3, but hopefully you know the answer is 1 and 2. So 1 plus 2 equals 3, and 1 times 2 equals 2. So my answer is x plus 1 and x plus 2. We could also write that as x plus 2 times x plus 1. It doesn't matter the order. Okay, let's do some more of these. Okay, here's number 2. Go ahead and write it down. It's x squared plus x subtract 30. We are looking for, first of all, is there a GCF? No. So we are looking for two numbers that when multiplied, I'm going to go ahead and draw my x games over here, that when multiplied give me negative 30, and when added give me a positive 1. So I want to look at all my options here for factors of negative 30 when I multiply them. I've got 1 and negative 30, 2 and negative 15, 3 and negative 10, and 5 and negative 6. Now if I multiply all these together, they're going to equal negative 30. But do any of these added together equal positive 1? Well, 1 minus 30 equals a negative 29. 2 minus 15 is a negative 13. The next one's negative 7. And this one's a negative 1. But I could see that if I changed this 5 to a negative and the 6 to a positive, then that would give me a positive 1. So my two numbers are negative 5 and a positive 6. So negative 5 plus 6 equals 1, and negative 5 times 6 is negative 30. So my answer is x minus 5 and x plus 6. Number 3 is m squared subtract 9m plus 20. I'm looking for two numbers that when multiplied give me 20 and when added give me a negative 9. So think of two numbers that when multiplied give you a positive 20 and when added give you a negative 9. Hopefully you were able to figure out that that is negative 5 and negative 4. Negative 5 plus a negative 4 is a negative 9. Negative 5 times a negative 4 is a positive 20. So my answer is m subtract 5 times m subtract 4. And the way to know if I did this right, what I would do is I'd go ahead and distribute this back through. I just multiply it back out. M times m is m squared. M times negative 4 is negative 4m. Negative 5 times m is negative 5m. And negative 5 times negative 4 is a positive 20. And here I have like terms, negative 4m minus 5m, which gives me my negative 9m. Number 4 is p squared plus 3p subtract 40. Okay, once again, I'm going to do x games, and I'm looking for two numbers that when added give me a positive 3. That is just not wanting to make an add there. There we go. Added give me a positive 3, and when multiplied give me a negative 40. This one might be a little trickier. If you're having a hard time figuring out, start writing down the factors of 40. 1 and 40, 2 and 20, 4 and 10, 5, and 8. Are any of those 3 apart? Well, that's our 5 and 8. But one of them has to be negative because I'm looking for a 3 and a negative 40. So which two numbers, if this is a positive 3, I know that this has to be a negative 5. Because negative 5 plus a positive 8 would give me a positive 3. So my answer is X. Oh, that's a P. P subtract 5 times P plus 8. If you wrote it as P plus 8 times P subtract 5, does not matter. Same answer. So either one of those would be correct. Okay, number 5. C squared subtract 6C subtract 40. And I'm going to give you guys about 30 seconds to figure it out on your own. See if you can do this one by yourself. All right, let's see how you did. Two numbers that when added give you a negative 6 and when multiplied give you a negative 40. That is going to be 4 and negative 10. 4 plus a negative 10 is a negative 6. 4 times negative 10 is a negative 40. So my answer, C subtract 10 times C plus 4. Or I could go the other way, C plus 4 and C subtract 10. Either answer would be correct. Okay, I'm going to give you both 6 and 7 now. Number 6 is going to be W squared minus 9W subtract 22. And number 7 is going to be N squared plus N subtract 12. Try both of those. I'm going to give you a minute, and then we'll go through the answer. Okay, let's go through each one. Go ahead and erase number 7 first so we can go through number 6. What two numbers, when multiplied, gives me a negative 22, and when added, gives me a negative 9? Well, that is going to be negative 11 and 2. So I have W minus 11 times W plus 2. Negative 11 plus 2 gives me a negative 9. And negative 11 times 2 gives me a negative 22. Okay, number 7. we have n squared plus n subtract 12. And once again, two numbers that when multiplied give me a negative 12, and when added give me a positive 1. That would be n plus 4 times n subtract 3. Or I could say n subtract 3 times n plus 4. Does not matter either way. They're both correct. Okay, now we're going to go ahead and we're going to use either X games or factoring, X games of the GCF to the rest of these problems. So what this is going to do is require you now to use both methods that we've learned and decide which one you need to do. So let's start with number 8. Number 8 is z squared plus 6z plus 8. The first thing I need to decide is there a GCF? Well, I have z times z plus 2 times 3z plus 2 times 2 times 2. And I can see that none of the terms, this is a term, this is a term, this is a term, none of them have anything in common. So there is no GCF. So the answer to that is no. If I say no, that there is no GCF, then I'm going to use my X games. So now I'm looking for two numbers that when added give me 6 and when multiplied give me 8. Two numbers that when added give me 6 and multiplied equals 8. Hopefully you saw that that is 2 and 4. So my answer here is z plus 2 times z plus 4. Okay, number 9. Number 9, we have 6y squared plus 3y. First question I ask myself is there a GCF? I have 2 times 3y plus 3y. Well, I can see that they both have, each term has a 3y, so yes, there's a GCF. If the answer is yes, then you take it out. So it's 3y times, what's left inside? A 2 and a y plus 1. There's my answer. So number 9 was just like what we did on homework 11-4 and on the warm-up today. Okay, we're almost done. I think we have 6 problems left. Number 10. R squared minus 4r plus 4. So first of all, decide, is there a GCF? If the answer is yes, you take it out. If the answer is no, you do X games. Okay, here's number 11. 3k squared minus 24k plus, I'm trying to see what that says there, 45. Okay, I'm going to go ahead and give you number 12 as well. Number 12 is 8h to the third power minus 12h plus 20. I'll give you about 1 more minute to finish up 11 and 12. Okay, let's go over number 10. Go ahead and erase these here. Okay, so first of all, is there a GCF? So if I write it out, I have r times r minus 2 times 2 times r plus 2 times 2. So I can see there's no GCF because they don't have anything in common. So we're going to erase that. So that means I'm going to use X game. So I'm looking for two numbers that when added together give me -4 and when multiplied give me a +4. Hopefully you saw that that was a -2 and a -2. So it's r subtract 2 times r subtract 2, or you could write this as r subtract 2, the whole thing squared. So either way you could write that answer. Okay, our next one, number 11, was 3k squared minus 24k plus 45. First thing I want to do is see if I have a GCF. So I have 3k minus 2 times 2 times 2 times 3k plus 3 times 3 times 5. And I can see they each have a 3. So my 3 is my GCF, so I'm left with k squared minus 8k plus 15. But I'm actually not done, because then I'll notice that right here I have a leading coefficient of 1 and a trinomial. So let's see if I can use X games now to factor what's inside here. So I'm looking for two numbers that when added give me -8 and when multiplied give me 15. Well, that is a -3 and a -5. So my final answer here is actually going to be 3 parentheses k subtract 3 times k subtract 5. And that's my final answer.